Good afternoon. Hi, Charlie.
Hi, Erik.
Thanks for joining me today. This is exciting. I'm looking forward to this conversation this afternoon.
Yes, me too. Me too. It's great to be back from the new year and looking forward to 2024. Welcome everybody joining. We'll give it maybe a few minutes to let everyone join us.
Yeah. Right. I do see the stream is live on LinkedIn, so let's get started. Well, Charlie, you and I have been in the search space for quite some time, and it's great to connect in 2024 and take a real stock of where we are and what's going on and what's new. Well, let's start with some quick introductions for those who haven't met us yet or haven't seen us in person. Charlie, why don't you go ahead and give us a little bit of a background about you and what you've been working on in the search space for the last couple of years.
Sure. So yes, I'm Charlie Hull. I've been in the search business over 20 years. I ran a consultancy called Flax in the UK for 17 of those years, and then 5 years ago I joined Open Source Connections. I've worked with governments, big companies, small companies, e-commerce, libraries, you name it, implementing search solutions. And I think my focus is really on the practical and pragmatic. I like to build things that work. And Open Source Connections, I help run our events. I run some of our engagements, our trainings and discoveries. And I think at the moment, like most people in the search space, we're adjusting to this new world of AI. We're adjusting to a lot of things changing over the last few years, possibly addressing some old challenges and certainly bringing in some new challenges. And we're really trying to see how we can turn these new improvements and these new innovations to the advantage of our clients.
Excellent, amazing. I'm seeing some folks join in the chat here. Thank you for that introduction. My name is Erik Schwartz. I've been around search for going over 25 years. I started in the mid-90s building digital libraries. So tackling the problem of physical space overload and digitization and trying to find content and images. And then we started building digital libraries for libraries and government agencies in the late 90s. And then in the early 2000s, I switched teams, and joined the vendor space. And I worked for a number of search engine vendors going back into the early 2000s, working for a company called Convera, who had a product called Retrieval that was quite popular for quite some time, and especially in the government space and in the pharma space around that time. And then Retrieval was sold by Convera to a company called Fast, the Norwegian competitor. And 9 months later, Fast was acquired by Microsoft. So I was a Microsoft product manager in the SharePoint team for some time. And then in 2010, I joined Comcast, building scalable enterprise search solutions for Comcast that powered their video experience. And then in 2018, I literally jumped ship and came across the pond and found myself in sunny London working for Elsevier, the world's largest publisher of academic peer-reviewed literature. And at Elsevier, we worked on a number of projects, but most recently we worked on Scopus AI. And Scopus AI was an integration of ChatGPT and Scopus, this large data set of highly trusted abstracts and indexes that people use to assess their careers in the academic space. Now I've left, and Charlie and I ran into each other at a meetup in London a few months back and said, listen, let's get on internet and let's get on LinkedIn Live and let's have a conversation about how AI is changing the game entirely in search, or maybe not changing anything at all. So
yeah, I think you're right there, Erik. I think that's really the big question. What's changed, what hasn't, how do we put the two together? And I mean, one thing that, we can say is search these days is something that people expect just to work. It's table stakes. It's something that every organization that shares information or wants you to, buy something or whatever it is that they're using search for, it's expected to just work. And we have the old cliche that everyone just wants it to work like Google. Well, in a way, you need more than that. You need something that works specifically for your users, for your content, for the purpose that it's designed for. And you can't get away with something that doesn't bring back relevant results or takes too long to do so. But like there's always been challenges with search. And I think when it comes down to it, search is a question, good search depends on matching what the user wants with what the provider has. And very often the problem is that these two things are described in different kinds of language. And if your user types in something and it doesn't match something in your catalog, you've got a problem. And that's pretty much our bread and butter as search consultants, is helping people solve that situation. So given that we've always had the challenges that users and providers don't speak the same language, this is why it's so exciting to hear about some of these developments with AI, because they promise to help with that understanding gap. We all know about ChatGPT. We all know about large language models. We hear about them pretty much every day. We certainly hear about them a lot on LinkedIn. And they promise great things. They promise to close this gap. They promise to help computers understand what people are typing or speaking in a way we've never been able to manage before. And that's why it's such an exciting time in the search business.
Yeah, no, I completely agree. I remember going to working for Fast back in the 2000s, back in the noughts. Fast used to have these annual events called Fast Forward, and they had this. It was a big, flashy event, and it was really, it was like a red carpet event. The way everyone came out and told their story. But I remember at the time, Fast did an amazing job of really simplifying this technology that we called search and we love, called enterprise search, by really saying, as you said earlier, the problem really is about connecting content with intent, right? Intent and content, and our experience over the last couple of months and last year since ChatGPT launched is that some of these things that we used to really struggle with, like understanding language, understanding classification, understanding meaning, understanding nuance in words, really gets accelerated by some of these technologies. So for example, just understanding sentiment. I remember when we were doing early work for the government in the late 90s, the government would pay a lot of money, and these are like big three-letter agencies that we can't really mention by name or by purpose. They would pay a lot of money just to have text analyzed and extract sentiment analysis on the text. And this was a real big information retrieval problem. And now it seems like these large language models can just do it out of the box. I can throw out some text and say, is this positive or negative? Is this happy or sad? Is this someone, right? And so that's a major achievement. But it can really, it seems like, Charlie, and if you agree with it, it seems like it's really moved us forward in the ability to understand natural language.
Well, that's certainly part of it, and that again is something traditional search engines have struggled with. I always say that traditional search engines they don't understand the language that you contain within their indexes. They don't know what a word means. They know how many times it appears. They know how many times it was in your document. They know if the user's typed it. They don't have any concept of understanding the meaning of that word, or whether it's close to the meaning of another word. And that's always a problem. And we have worked on this for years. There have been natural language processing solutions to some of these problems, and even manual ones, such as manually adding synonyms. That's a common solution. Or spelling suggestion, where you correct a word to the closest word in terms of characters to the word you have in your index and hope that's the right one. But I think the other thing that we have been is locked into certain paradigms. We're used to the way a search engine works. We type in a query. Nowadays, we might type a longer query, but in the old days, 2 or 3 words. And then we get a list of results. And then we have to do some more work, because what that hasn't done is actually solved our problem. If I say, what's the best holiday in Spain to go on with my 2 kids, where there's a swimming pool, I want to go in July, and I just get a list of results. I've still got to do research to figure out if those results are actually what I need. So I think one of the interesting things here is we have a chance here to bridge that gap again and go not just from a question to a set of results, but a question to an answer directly. And I think that's really exciting. We might even be moving away from that age of the 10 blue links, the classic search engine pattern. Another way of thinking about it is maybe if you are a content provider and you have a huge collection of data, the people coming to that data afresh, or people who aren't very experienced with that data, really have no idea what's in that collection. They don't know, what your data is about. So sometimes you have to sort of introduce them to it, and maybe this is a way to give them a path, a happy path into the data, so you can start them on those journeys. And we've all fallen down those rabbit holes of research. But if you're a lawyer or a medical scientist, for example, these are important things you're carrying out, but you need somewhere to start and somewhere to begin your journey of information seeking. So I think we're even seeing the possibility here. We can move away from traditional search engine models. And certainly when you use something like ChatGPT, you're looking for an answer to your question. You're not looking for a list of 10 blue links. And I think that's a really interesting difference.
Yeah, I love that you bring up this whole notion of how does a user know what's in a corpus or in a data set when you get to a website. This is a metric we talked about a lot, which is zero results for a search engine. And when a user goes into a product and types a search question, whether they're looking for that beautiful holiday, now you get me thinking about the beach and the Algarves, or the California of Europe, as I heard it called recently, which is, I'm not sure if that's insulting or helpful. But when you type in that query and you try to get a result back and you get nothing back, what happens, right? The user takes it upon themselves as, oh, listen, I must have asked a bad query. But what if they don't know what's in that repository? How do they don't have a clue? They don't. So product managers spend all this time kind of, here's a sample query, here's something that might work really well for you, right? But one of the things that we learned with Scopus AI, by leveraging technology called embeddings, which is mapping search and mapping the content into a vector space, into an AI space, was that we really allowed people to ask really expressive questions, and it actually seemed to work better the more words they put into it. And they actually got better results from the system, because we were able to connect different ideas into this embedding space, which started to create new opportunities, such as, this is a popular thing we see kind of all the time, right? Chat to your PDF. Who actually, I love that you made a comment on LinkedIn a few days ago, and someone said, who actually really wants to talk to a PDF file? But if you extract that a little bit and think about it, right? The use case that pops into my head is, listen, there's a whole bunch of documentation out there, or there's a big, long 50-page document that's been written, and I don't have the time to read it all, but I need to find out from this piece of information, is there something in here that's going to answer my question? And not just another link to another 20-page PDF, but bring it together in a summary to say, yeah, here's the answer that I'm looking for. Whether it's a new way to think about combining chemicals to make a new protein, or a new chemical compound, or if you want to look for job leads on the internet, right? How do you know how to ask those questions the right way so that you can get the right answers?
Yes, I think a lot of search operations, you tend not to just do one search. One does multiple searches to try and achieve a particular task. It is a conversation. So that idea of chatting to your PDFs isn't entirely crazy, but not that it sounds like a very interesting conversation. But what you're really talking about is some kind of interaction with your content. And this could be, as you say, looking for a job, looking for the job opportunities out there, and maybe applying to a few, or maybe changing your requirements a bit when you see that actually there are no Java jobs in this part of Liverpool. Maybe I need to look at Java jobs in Manchester or whatever. You're changing how you ask your question. You're having an interaction that's a multi-stage interaction with the system you're using. Interesting to bring up zero results, because this is a massive problem, particularly in the e-commerce space, which is an area we work in a lot. Frankly, if a user does a search on an e-commerce site and comes back with zero results, and you don't do anything to help them from that point, you're literally burning money. I've seen some terrible situations where even 20, 30, 40% of searches lead to 0 results. And what does the user do in that situation? They leave. They go and do something else. They don't think you have the thing they need. And you may well have it. You just haven't called it the right thing. And one of the fantastic applications of AI is actually saying, well, okay, here's the query your user gave me. Maybe we haven't got any results for that query, but what are the other kind of queries they might use to get the results we do have? What are similar questions they could ask, which are going to lead to a better result? And I think that's a really interesting application. And you're effectively asking the large language model, what are other ways to express this question? And you can do that and either ask all of those different forms of questions and bring the results together somehow, or just ask them sequentially. But it's a great way to get over that 0 results problem. And we're actually investigating this with a couple of clients in the e-commerce space at the moment. And I think it's definitely an idea that's got legs. But I think, yeah, I mean, this comes back to some of the, what I'd like to focus on myself, which is what are the practical problems we can solve with AI? What's actually out there that we can apply some of these techniques to.
Well, at the end of the day, Charlie, to your point, right? I mean, as businesses, as organizations, we have these data sets that we want to express, we want to share and make available to our customers. We really want to chart that happy path to the data, right? So that customers don't find time looking and finding nothing, but come and find value from the data we've collected and pulled together. But AI doesn't solve it all, does it?
No, and I think that's something we have to be aware of. This is another tool in the toolbox. This isn't an entirely new toolbox. Yeah. As search people, we have lots of ways to solve the problems our clients face. And I mean, to be honest, people come back to us all the time with the same problems. I'm not getting the right results to my query. My users are leaving. I'm getting 0 results. My users, are misspelling their queries, or whatever these things are. This repeats again and again. And as consultants, we see this all the time. But are there any new problems that we can look at that AI might solve? Well, I think there are. It depends on where who the person who is asking the question. So if I'm an executive, I'm very excited about AI because it's simply something that everybody is talking about. It's seen as a transformational change for businesses. You'll see lots of highfalutin articles talking about the massive change this is going to engender and how exciting it is. So as an executive, you're probably thinking, how can I get on this train? How can I do this? I don't want to be left behind. I don't want to be left behind by competitors, by the industry, by the technology. So I want to find out how to do this, but I don't necessarily understand what it can do for me. I don't understand the problems it can solve. Can I chat to my PDS? Why do I even want to do that? Will it help me sell more things? Will it help me bring more customers or keep the ones I have? If you're a technical person, you're probably a little more focused on specific problems. So again, 0 results. I see a certain percentage of people doing that, or I've got people searching in a different language than my content is in, and I need to somehow translate between the two. So the problems tend to be a bit more specific. And also, I mean, the technical people might have been asked by their executives, let's do some AI. And neither side really knows what that means. So trying to figure out what you mean by AI, what are the problems you're going to solve, and what are the appropriate techniques to solve it is another challenge. And what we can say is, I think all of our clients, all the people we work with on a daily basis, while they're still addressing the traditional problems of search, getting the relevant results, getting it performant enough, measuring how good it is, they're also all thinking about AI. And they're either doing it because it's exciting and everyone's said they've got to look at it, or they're really thinking about the practical things it might solve. But it's on everyone's agenda. I can't think of a client I've talked to in the last sort of 6 to 12 months who doesn't have a little AI research project going on somewhere in the corner. And the question is, what do we do with that little research project? Where do we go from there?
And the drivers here are, and we'll see how long this lasts. But you mentioned it, right, when you talked about the different sort of clients and the different actors in the project space. But the drivers here are very different. So it's not like technology teams are saying, listen, we need to embrace AI because it's going to help us solve all our problems, or product teams saying, listen, we've got to introduce AI because it changes the fundamental experiences. You've got C-suites now. You've got executives coming in saying, our investors, our boards, our management team needs to figure out what our strategy is here. Hey, Mr. Technology Guy, how are you going to use AI to help us drive our business, right? And there's some real pitfalls in some of those statements, right? Because it's not first of all, right, as you mentioned, there are a lot of prototypes out there. People are really good at building prototypes. There's a lot of Python, there's a lot of Jupyter notebooks, there's a lot of scripts with JavaScript applications running on people's desktops, showing proof of concepts that things are coming together. But it's still pretty costly to implement an AI solution at scale for all your customers. It's not like just putting a search engine in and just ramping up and horizontally scaling it. You've got to deal with hosting this thing, or dealing with token counts, or dealing with a lot of complexity with understanding what that data exchange looks like, and optimizing that conversation.
Absolutely, and I think, I mean, I heard at a conference some years ago someone asked the immortal phrase, the demo is never the product. And this is certainly true when you look at, when people show you very shiny commercial solutions. But I think the other problem is, because a lot of the AI stuff, a lot of AI stuff is very easy to plug together, at least initially. Now you can, set up prompts that can do magical things. You can drop notebooks together. All of these moving parts seem very easy to plug together. Yeah. To build something that's got 100 documents, or can do some simple things, to show off your AI capabilities is very easy, but it's kind of deceptively easy, because how do you then take that to production? And that's the complicated bit. You can't take a bunch of Jupyter notebooks and make that a production system. That just doesn't work. A lot of the technology that's appearing very, very quickly is not necessarily battle tested for production, isn't necessarily scalable. So we've got some big questions now about how do we move from that era of the prototype and the demo to something that works for real users in real situations, and scales and is solid, and something you can roll out to production without things going terribly wrong. And there are issues with AI. We know that there are issues with prompt injection, where people can make your AIs do strange things. We have that case of the lawyer who went off to court with a set of cases to base his arguments on, and then the judge threw it out because he discovered the cases had been entirely made up by the large language model. So, and that's not the only example. So there's big risks here, and I think again, one of my jobs as a consultant is to try and reduce those risks for my clients. To make sure that whatever they're trying to do comes with as low a risk as possible. At least we understand those risks and we can ameliorate them. And I think the AI world has brought a whole new different set of risks for us to deal with. But I think if we go back to some of the principles that we know and love as search people, we can maybe look at some of those and figure out ways around them, or ways to cope with them.
Yeah, you mentioned some of the tools that are emerging these days, and there's a couple of big frameworks that are starting to emerge as real accelerators for building demos and prototypes. LangChain is a big one that everyone talks about. I was at an AWS event. It was actually, AWS had their natural language processing day in London back in September, and it was 98.9, and this is exact figures, AI, the content, right? It wasn't natural language processing at all. We weren't talking about, sentiment analysis. We weren't talking about different ways to process language or understand language, or ontologies, or sort of all the traditional knowledge management things and taxonomies, and as Tito mentioned, different ways and hacks that we've used to represent language in the past. But it was all about AI and LLMs, but their demo was they put together LangChain and showed you how you can build a solution that doesn't hallucinate in drag and drop. Like, we have a wizard that allows you to build to access your data, and they're using LangChain to do that demo. And it's great to show that proof of concept and build some interesting complex ideas, like introducing retrieval augmented generation, which we'll talk about maybe towards the end a little bit more. But going back to your comment that you just mentioned about the scale, another popular framework that's out there is something called Llama Index. And I just saw a post from Jerry, who's the CEO of Llama, or founder and CEO of, everyone's a CEO these days. It's becoming an undervalued acronym. he said, listen, we've got a solution now that puts together thousands of documents, right? And I have to laugh because we've been working in the enterprise space. Thousands of documents is right. I mean, that's someone's hard drive, right? That's not an enterprise solution, right? We typically work on the scales of hundreds of thousands, if not millions of documents in different languages with different structures and different styles. And this is the reality of that messy data that we run into when we connect to our search space. It's not all well formatted. It's not 10 nicely typed documents or even thousands of nicely typed documents, right? It's a lot, and this gets back to what are some of the practices, Charlie, that you recommend for your teams when you go down this path of AI? Are they different from what we used to do or been doing as data and information retrieval practitioners for the last couple of decades, or are there still some foundations and fundamentals that we need to reinforce for our teams as we go forward into these solutions?
I think, well, you've touched on one of them there, which is data quality, and this is absolutely fundamental. And I mean, search has always been one of those garbage in, garbage out problems. If you can't just throw a bunch of documents into a search engine and expect to get good results out the other end. And it's one of those truisms. Whenever you embark on a search project, you can spend 90% of the time tidying up the data and 10% of the time actually implementing the search engine. Because unfortunately, the promise has always been, well, we'll be able to search everything, just pile it all in there and it'll all just magically work. Now, the trouble is, if you've got a combination of different data structures, document sizes, different silos with different requirements, different file formats, it can be incredibly complicated to pull all of the information out of there and put it into a search engine index. But the quality of that data really matters. We've all seen the documents called specification final version 17 absolutely final, use this one ... and things like that, where you're not even sure if this is the canonical version of the thing that people should be searching for. Or user generated content is another huge problem. We have some clients who are in the marketplace space, so they're selling things that people have put up for sale with their own homebrewed inventions and slightly dodgy pictures and misspellings and whatever. Content quality is a huge problem in search because traditionally search just doesn't know that this is a misspelled word or this thing means that thing. But when you're looking at machine learning based strategies and LLMs, I mean, training models also depends on high quality data, and I'm pretty sure that these massive models that people like OpenAI are training, there's a huge amount of human effort that's gone on behind the scenes to tidy up the training data to make it reliable and to pull out things you don't want in the training data. So that human effort to clean the data up and make it a decent structure, that isn't going away. We're still going to need to do that. And I think the quality of the eventual solution will depend hugely on the quality of the data you feed into it. Scale, as you said, is also a huge problem. You're still going to need to go out and gather all that data, put it into some kind of order for whatever your system is. You're still going to do that ingest pipeline, as we call it, stage is still very important. So that's not going away. And I think, especially if you want a good quality AI-driven result, you're going to have to make sure that the stuff that goes in at the beginning is good as well. Another thing which kind of is connected to this is security, and this is particularly important in the enterprise space. Enterprises are weird. They sometimes actively hide information. They don't let you have access to things. There's a silo full of invoices that is only allowed in if you have the appropriate runes from the chief accountant to get in there. You're only allowed to get in there, which is fine and annoying when you're trying to build an index. But what about the whole problem that certain people shouldn't be able to see certain things? And every enterprise has security and access control requirements, and this has to be reflected in whatever system you're building on top of it. You don't want a system where a lowly paid employee can happily Google the salaries of the CEO and the boards. Even knowing that a certain thing exists can be dangerous. One of my examples I give is, I don't know, a document talking about the new office that they're going to move to in a different town. Now, this new office is a quarter of the size of the old office. So anyone with any sense would, if they found that document existed, they're going to go, hang on, are we laying off 3/4 of our staff? So even knowing that a particular result exists in a set of search results can be a problem. Now, the trouble is with a lot of AI technology is you don't have this same concept of security. It's very hard to put that into the model. You can't say to the model, learn all these things, and all, by the way, you also have to learn all the security permissions. That's hard. So you need to think about security all the way through from one end to the other. And I think that's probably the Achilles heel of some of these solutions. To maintain that end-to-end security concept it's going to be very hard. There are some ways around it. But so that would be maybe my first two things to be concerned about.
Yeah, no, those are real, real tangible problems that have to be focused on an AI solution. You think about integrating into the enterprise, and even when you think about your data quality, your data security, the measures of success, what good looks like, still fundamentally doesn't change, right? The way we're going to evaluate a good search solution, the way we're going to evaluate a good AI solution is still fundamentally going to be the same. It's it's going to be measured in terms of employee productivity, amount of work that has to go into finding good results. Did you find good results? Are you satisfied? Are you engaged? Are you coming back regularly to use the solution? Does it effectively, does it help solve a problem for you, or is it just a tool that I have to use? I love to use the example of getting success in a tool, or getting a successful result in a tool, isn't always the best measure of success. If you look at like an HR tool like Workday, everyone has to get in and submit their end of year review, but it doesn't mean that process was pleasurable at all, or that was efficient for you, because they got it done, right? So the goal was achieved, but it doesn't mean that they enjoyed that experience, and they're looking forward to coming back and using that product again and again and again. So, I think one of the real lessons that we learned by implementing and scaling ChatGPT for across this data set for Scopus is how do we and this wasn't, if I looked at a year ago in my bingo card for 2023, I didn't think I'd be using hallucinate in a work context on a daily basis. But how do we prevent these large language models from really just making up stuff? They're really great at just saying something and saying it with a sense of confidence that you believe that it's just accurate. Even though like the legal case that you mentioned, it just makes it up because it's at the end of the day, it's just a language model, right? That does what it does. And so what are the techniques that we're going to use to start to prevent that hallucination?
Yes, I think I mean, this is the problem with large language models. They're very good at constructing plausible text and plausible results, but plausible doesn't mean correct. So I think in the enterprise context, in the professional context, when we need to believe, we need to get useful results out the other end, we have to think about ways of reducing this hallucination effect. And one of the techniques where people are talking about is retrieval augmented generation. And this is quite simple to understand. This is basically a two-step process. The first part is retrieval, and that goes right back to how search engines work. You do put a query in, get a set of documents. But then the second part, the generation, is where you ask your LLM, please construct an answer to this, the query we use, the question we use. But your sources are the ones we've just gone and got from the search system, and don't improvise and don't go outside the box. So, if I asked a question, for example, who are Tesla's competitors? The first thing I would do is go off to some kind of search index and get it, ask it the same question, and back come a load of documents about Tesla and its competitors. And then the LLM then constructs an answer based on that set of results and says, Tesla's competitors are Ford, GM, whatever the answer is. And it can also even refer back to those results. So it gives you a way of going to check the sources. which is great because it means you can say, well, here's my answer and this is what I'm basing it on. And then the user can then double check or feel some confidence in terms of where that answer came from. Now, retrieval augmented generation is very interesting because at the beginning of last year, I think a lot of search people were asking themselves, hey, what happens to my career now? Because everyone's saying that search engines are going to get replaced by AI. We're not going to need a search engine anymore. We're just going to need AI. It'll magically answer all our questions. But with the advent of RAG, we're coming back to some of those original principles. We're still going to have to build a decent retrieval engine. Yeah. And also we're going to have to measure how good that is and also how the eventual answer is. So all the the same techniques we've been using for making search better are still going to be important. So that's really interesting. The first step, the retrieval step, is also going to be able to take account of some of these wonderful new AI techniques, in particular vector databases. And they use the embeddings you mentioned there to find out where things are close together in vector space, and they give you some of those natural language facilities that we've been hitting missing. But you could, in theory, use a traditional search index as well, and in fact, in some cases, you might use a hybrid of the two. But the interesting thing about RAG is, again, it comes back to some of the old principles we've been dealing with search. They're not going away anytime soon because they can be used to build a system that grounds a language model in truth, and that's a really powerful technique.
Yeah, and that's and in full disclosure, RAG is the architecture that was behind Scopus AI. So we went and we made a vector search against our search engine, which was implemented in Elasticsearch. We created an embedding space for both the queries and the content, and we actually had in this case it was we were fairly constrained because the content was very clean. It's just abstracts, so it's really just a paragraph of text, not full text. So we didn't have to deal with all the sort of strategies around chunking through content and chunking through text, but really just sort of take that paragraph of text and match it to a query, and it did a fairly good job of finding equivalent vector space. There's a question in the chat about which vector databases to use, and Charlie, you and I were talking about this in our prep call earlier today. How would you advise people on selecting vector databases?
Well, that's an interesting one because actually it's a wider question than just the the vector databases. The funny thing is that pretty much everyone's been adding vector features to their solution over the last couple of years. So you've got a whole sheaf of choices. You've got traditional search engines, be they open source like the Lucene-based ones like Solr, Elasticsearch, OpenSearch, or be they closed source, Algolia, Coveo. All of these let's call them old school search engines are adding embeddings and vectors and whatever. So now they may not be as fast as some specialized vector databases, but they may be the technology you already have, you already understand. And importantly, they have all the standard search features as well. So you can do things like hybrid search. And they're a good solid solution. So that's one option. And there's always a value in not adding yet another technology to your collection of technologies you have in your company. Stick with what you have has value. Then you've got the pure play vector databases, and there's the questions asked. I mentioned a few there. Weaviate, Quadrant, Milvus. There's many more. Yeah. And these tend to be startups that have relatively recently appeared, and they're getting a lot of funding, a lot of excitement around them, and they're optimized for this vector search use case, but sometimes they lack some of the traditional search features. They may not be very good at the the traditional search. You may need to put together a hybrid with your vector search. Again, small, fast-moving, well-funded companies. We don't know where these are going. They won't all survive the next few years. Once the VC money runs out, then they need a business model.
Well, they'll get acquired by somebody bigger.
They might get acquired. The technology might go away. But this is the thing about fast-moving new technologies. There's always a bit of a risk there. But they're often very fast. They've got some fantastic people working for them, doing a huge amount of work in developer relations, for example, and helping people use them. And the educational aspect is fantastic. Then you've got cloud providers, people that are providing things that you just you rent your search services as you might do through the cloud. And there are full solutions. Well, are they full solutions? People like Google and Amazon are producing these. You've got traditional database vendors. There's a PG Vector, which is a fantastic open source solution for Postgres databases. You've got people like DataStax are adding vector search to the database. Oracle are
Oracle, Neo4j is adding to their graph database. Mongo is adding it to their Atlas solution, right? And so everyone's sort of becoming right. So I love your advice, which is you don't have to necessarily introduce new technology. Stay where you are, right? Yeah. I'm gonna start something in the chat here because we're about running out of time here. I'm gonna open up for any more final questions here. I'm gonna share a link in the chat here, which I posted on LinkedIn a few weeks back, which is a ongoing data an Excel sheet that lists out all the vector databases, and I'm gonna share it up here.
If it's the one I think it is, that's a fantastic resource. I think the person who started it didn't quite anticipate how much this would have grown, but it's one of those collaborative efforts to lots of input going into it to try and get some kind of idea of the landscape. When you're looking at these technology choices, you've got to be very careful because there's commercial pressures. If everyone wants to push their own favorite solution. But it's horses for courses. Really think about what works for you. Don't get seduced by the shiny, and think about all the different factors. Is it a good idea to stick with what you know? Where are you going to find people who might understand this technology? How much is it going to cost you? What's the risk of migrating from one to the other? All of these features, these things are worth considering, but it is a very fast-moving landscape, and you need to be careful about your choices. But yeah, it's exciting as well because there's so much energy going back into the search world now. That's really exciting for us who've been in this business for a while. Again, solving some of those original problems in new and innovative ways, and also creating entirely new solutions that are grounded in search. And I think that's why it's going to be a very exciting year coming forward.
Yeah, no, I agree, and I think that's the if you're going off and you want to build a prototype, Pinecone or Weaviate are great because they're already cloud native and you can just spin it up really quickly. If you've got something in already running in your enterprise, use that. For some reason, it's not allowing me to post the chat here, so I'll add it on to the meeting after we're done here. All right, great. Well, this was a fantastic conversation. I can't believe 40 minutes went by. Yeah, the Google spreadsheet, Erik. That's the one. You have it already. That's the one I was going to share. Yeah, I know some of the guys that I know are working on this, so it's great to see this resource come out and come around. So here's a question. Let me put it on the screen here. So here's a question from Peter. Elaborate how we tested our vector search to ensure that it returned relevant results. So this is a great question. This is getting into the Scopus AI solution that I mentioned briefly. Thank you, Peter, for the question. So a couple of things were done. First and foremost, when we were introducing vector search at Elsevier, we really took a very traditional approach to validating our results. The very first thing that we did is we did a double-blind test where we took BM25 results, so regular TF-IDF, regular search results coming from Elasticsearch, and vector results, and we randomly blended them together. So we created a top 5 list. We made a very simple tool that we then put in front of editors. So Elsevier has 2,700 journals that it publishes, and so we've got this massive group of internal subject matter experts. We sat down, we asked them to generate a query, we asked them to run the query and then evaluate those results. And then we were able to compare, irregardless of of position and space, how those results did against each other, and then rank them just on a scale of 1 to 5. Is this close or is this accurate? This was also where we were able to experiment offline, and also get the editors to try to expand their queries and put more query terms in. And they saw that once they started doing that, that the set of results that were coming back to them were, in some cases, there's feedback from the team, was absolute game changer to my workflow. The fact that they could start to ask these questions about these disparate domains or connect 2 different domains together in different ways that they hadn't thought about, without having to jump through all the hoops of a really complex query language. So that's how we started to look at the vector results and ensuring that vector search was actually returning the results. The other part of this, which is also super interesting, maybe we'll find a guest that we can speak to maybe next time to talk about how this is working and the progress that's happening there, is now once you've got a couple of stages here that are new. So it's not just putting 10 blue links into a screen and getting a user to evaluate them. When you go and you take that solution and you have a large language model summarize it, yeah, so we were able to use prompt engineering to make sure we referred back to that source candidate list. But then we also had it generate a summary. And so what we ended up doing is we ended up using a technique which is also documented in the academic literature, which is basically having the LLM evaluate the LLM. So how, asking it, how is it doing at producing a summary? Does that summary make sense? Is it cohesive? Is it intuitive? Does it answer the question appropriately? And so effectively this way. So and it's not like cheating in your homework or solving your homework and looking at the answer book to solve your homework. We had one model generate the summary, and then another model come along and do an evaluation and come up with a systematic way of doing it reproducibly. And it's a great case study that I'd love to share maybe in more detail at some point in the future. So
just to add there, I think this is going to be the secret sauce for anyone trying to build an AI powered search system. I think you need to do measurement. You need to get some idea how good things are. And traditionally, you do this with human judgments, as you've just mentioned there, or you do it with some kind of clicks, which is noisier, but potentially easier and cheaper to gather. And you evolve some kind of metrics that say, how good were the results for this query? And we can do that with, with vector search. We can do that for the R part of the RAG. But there's also a whole page evaluation where you just, you look at all the results as one thing, and that potentially is also something we can use. And or that a similar sort of situation for the G part of the RAG. But you've got to look at all of these things. Unless you've got some numbers that tell you how good your system is, you're just operating in the dark. And this is something that we've been focusing a lot on here at OSC. We have a tool called Cupid. This is open source, and that lets you gather these human judgments. So we've recently managed to add one of the new vector search engines as an option for Cupid. And in fact, you can add any search engine to Cupid now. So we'll be writing about that in the next few days. There'll be a blog post coming out showing the improvements. But unless we have that basis of measurement, you can't improve something unless you measure it. We'll continue to stick to our guns on that one, even as we work on these new solutions. And I'm also encouraged to see there's a lot of other people working on evaluation for AI systems. And as you say, one option is to get another AI to monitor your AI. Avoiding the mark your own homework problem is a difficult one, but I think it does give us some options to really scale up some of this measurement, because you can generate effectively synthetic judgments of how good a set of results are. Cupid for the question who answers, QUEPID. That's Cupid. But we'll put some links in the LinkedIn meeting as well. There's been another question here. The combination of sparse and dense vectors. Do you want to pop that question up for us, Erik?
Yeah,
it is from another Erik. A lot of fields in my data set are 0 values. That's an interesting one.
Right.
It feels to me like probably that the sparse vectors is more likely to work here. But you're not going to do, I mean, try both and test it. See what gives you the best result. A lot of search is best served by experimentation. Try something out, very quickly evaluate it, see if it works, and see if it drives your business forward. And that's because there's so many different things you can try with search. It's sometimes hard to know which will give you the best benefit. So try it out. I would say try both.
I agree. Yeah, that was good. That's I mean, there are some optimizations when you do have a lot of fields that are 0 values. I mean, there are optimizations you can make, and that's a place where you can evaluate different models. You can evaluate also different data management techniques, right, or data modeling techniques. where you can, instead of trying to treat them as independent fields and sort of keeping them persistent as you create the experience, you maybe create more of a narrative, right? Take those things, bring them together into more of a summary before shipping them off to the large language model. One thing that we'll come back and talk about next time as well is this technique that my colleague at Elsevier, Adrian Radischel, came up with, which was RAG fusion. And so this is building on top of retrieval augmented generation and using RRF, or reciprocal rank fusion, to basically fire off a bunch of different queries. And those queries were then, this is like a query intent problem, right? Where we go off, we ask the LLM, hey, here's the question. Try to think of different ways of answering that question, or explore this topic from a couple different areas. Fire off those queries in parallel, and then use RRF to quickly find the overlaps to bring the best results to the top that we can then use for summarization. So there's a couple of really interesting techniques that you can now start to leverage with some of these tools. So, all right, great. Let's see. We're getting to the top of the hour here, so we're going a bit beyond. Yeah, Peter also recommends Cupid. Thank you, Peter, for that. Great to see you here.
Interesting point there from somebody on the chat, talking about most of the current solutions are variants of the HNSW algorithm. That's true. Yeah, performance will not be as strong. Yes. Yeah. I mean, again, you might raw performance may not be a problem for you. It may be a problem for you. It's going to depend on your use case. It's certainly not the only thing you should be choosing technology based. Reciprocal rank fusion is the technique for RF.
Reciprocal rank fusion. You can definitely Google that. There's also a blog post that both Llama Index and Llama Index and LangChain picked up RAG fusion, reciprocal rank fusion, as a methodology they're using for query expansion. Which is kind of funny too. Even the high-end version of the enterprise version of Elasticsearch, their new 8, I think it's 8.11 they're up to, and it's hard to keep up with the versions. They are charging for RRF as part of the product. So it'll be interesting to see how that one plays out. But yeah, great. Thanks for sharing some of those links. Thank you, Daniel.
Yeah.
All right, amazing. Well, Charlie, this has been amazing. What a great chat. So great to see all of this engagement. So great to see so many old friends in the chat saying hi and asking good questions. And great to talk to you. This is fun.
Well, it's been fun. And if people want us to, maybe we should do this again sometime soon. But yeah, it's been good fun. I'm going to put a little plug in for our Haystack Search Conference. You can see the logo above my head. We have this in the US in April, and the call for papers is open. You can just go to haystackconf.com. My colleague Daniel will post a link into the chat. And we'd love to have submissions for that. And if anyone would like to come to the conference, or it's a great chance for people to get together and talk about more of these subjects. I know several of the people who've joined us today have been to Haystacks in the past, so I'd love to see more of you there. But yeah, thanks, Erik. It's been great fun. Let's do it again sometime.
Let's absolutely do it again. Thanks, Charlie, for joining. See everybody at Haystack, hopefully in April, and have a great rest of your day. Oh, Adrian posted that RAG fusion article. Brilliant. Thank you so much for sharing that. So we'll pull that up. All right. Bye, everybody. See you soon, and talk to you again in the near future.
Bye.
Searching.